Question 1. Aircraft is 3 degrees off the required track at a range of 120 miles. How far is the aircraft off the required track? So let's solve this question. So let's say we are at A and B. A is your departure point, B is your destination point. So A to B, while going from A to B at a distance of 120 nautical miles, you are some distance off the required track. Now they have not mentioned whether left or right. We can consider left. And track error is given to be 3 degrees. So AB becomes our planned track or the required track. AC becomes a track made good. And 3 degree becomes our track error angle. Now we have to find this distance. We have to find this distance, which is your distance off track. Distance off track. So let's use the formula angle equals to distance off track divided by distance gone into 60 into 60. So what is the angle? Angle is 3 degree. Distance off track we have to find out. Distance gone is 120 into 60. Therefore distance off track will be equal to 3 into 120 divided by 60, which is equal to 6 nautical mile. So you are 6 nautical mile to the left of the track or to the right of the required track. 6 nautical miles left or 6 nautical mile right. So that is your answer. Okay, so draw the triangle, label the triangle, and after that proceed to solving the sum using the formula. Next question. Aircraft is 2 miles off the required track at a distance of 40 miles. What is the angle? What is the track error angle? So same, let's say we are at A flying towards B. So this distance is 40. Distance off track is 2 miles and we have to find now track error angle. So now AB is your planned track. AB is your planned track. AC is your track made good. AC is your track made good. Now you have to find track error. And this is your distance off track. This is your distance gone. Track error equals to distance off track divided by distance gone into 60. Distance off track by distance gone into 60. So distance off track is 2 nautical. Distance off track is 2. Distance gone is 40 into 60. So track error angle will be equal to 3 degree. Track error angle will be equal to 3 degree. Now this can be left side or right side. It's not given in the question. So 3 degree to the left or 3 degree to the right. 3 degree left or 3 degree right. So same, draw the diagram, label it. After labeling it, use the formula, substitute the values. Next question. Aircraft leaves A and goes to point B at 95 nautical mile distance. Having flown 35 nautical miles, aircraft position is found, which is 7 nautical mile to the right of required track. What is the track error? Okay, so let's draw this A and B. Okay, So AB, total AB distance is 95 nautical miles. Out of this 95, you have flown 35. You have flown 35 nautical miles. Okay. And uh, after flying 35 nautical miles, you are 7 nautical miles to the right of track. So 7 nautical miles to the right hand side of the track. Okay. So AB becomes your planned track or your required track. AC becomes your track made good. This is your distance off track. This is your distance gone. So now let's calculate track error. So track error by formula is distance off track divided by distance gone into 60, right? So how much is distance off track? It is 7 nautical miles. Distance gone is how much? It is 35 into 60. So track error angle is 12 degree. It is 12 degree. Okay. So this is how you do this part. Second part says what alteration of heading is required to fly directly to B. What alteration of heading is required? So now look at this. So now to do this, you will have to draw two triangles, 1 and 2. Now A, B and C. Now this is how much track error is 12 degree. Okay. So track error is 12 degree. So if this is 12 degree, this angle will also be 12 degree. Corresponding angles are equal. Now let's calculate this closing angle. Why we have to calculate closing angle? Because here they have mentioned that you have to fly directly to B. Now when you have to fly directly to B, you will use out of two methods. So the first one is double track error method and the second one is track error and closing angle method. Out of these two methods, you will use the second method, which is track error and closing angle method. Okay. Using this method, you will be able to fly directly to your destination. So now track error, we have found 12 degree, 12 degree. Okay. So initially your aeroplane was somewhere here. Okay. So now next we have to find this angle, which is a closing angle. So closing angle is again distance of track upon distance gone into 60. Now if this distance is 35 nautical miles, the remaining distance will be 95 minus 35, which is 60 nautical miles. So so closing angle will be 60. Distance of track is 7 into 60. So closing angle will be equal to 7 degree. So if this is 7 degree, this angle will also be 7 degree, which is your alternate angle. Okay. So the final answer is the alteration of heading required will be alteration of heading required will be a total of 12 plus 7. A total of 12 degree plus 7 degree. 12 degree is your track error, 7 degree is your closing angle. So total becomes 19 degree. Total becomes 19 degree. Now which direction will you turn? Your B is to the left of your direction, is to your left side, right? So you will turn 19 degree left. You will turn 19 degree left. Okay. So what alteration of heading? So you will alter your heading, whatever the heading of aircraft is. From that heading, you will subtract 19 degree to go directly to your destination. Bravo. Next case, what is the drift? Now by definition, drift is the angle between your heading and track. Is the angle between your heading and track. Okay, drift is the angle between heading and track. So now in order to find drift, we should know the values of heading and track. But in this question, we have not been given any values of heading or track. So finding drift is impossible. So that's why drift cannot be cannot be known. Drift cannot be known to us. Okay, because we should know the values of heading and track. Next question. Aircraft is flying from Oxford to Cambridge at a track of 074. So required track to go from Oxford to Cambridge is 074 degrees. A total distance of 70 nautical miles. Heading of aircraft is 065 degree. Okay. Having flown 30 nautical miles, the pilot pinpoints aircraft 4 nautical miles to the left hand side. So let's draw this. So you are going from Oxford to Cambridge, and after flying 30 nautical miles, you have found yourself 4 nautical mile left hand side. Found yourself 4 nautical mile to the left hand side over Cranefield. Total distance is how much? It is 70 nautical miles. So after traveling 30 nautical miles, the remaining distance will be 40. The remaining distance will be 40. And this will be your track error. So this will be your planned track. Will be your track made good. So what is the track error over Cranefield? So let's find track error. So track error will be equal to distance of track divided by distance gone into 60. So distance of track is 4, distance gone is 30 into 60. So answer is 8 degree. Track error angle is 8 degree left. 8 degree left hand side. Next, what is the track made good from Oxford? Now your planned track is 074. So let's write it that here. So your planned track from Oxford to Cambridge is 074 degree. And this is your track made good to the left hand side of planned track. So what is the direction of track made good? So track made good will be planned track minus track error. Why minus? Because it is to the left hand side. And as we go towards left hand side, all our direction values decrease. So planned track is 074. Track error is 8 degree. 74 minus 8 is 066 degree. So track made good is at a valuation of 066. What was the expected drift and what is the actual drift? Okay, what is the expected drift and what is the actual drift? So now is the drift. What is drift? It is the angular difference between heading and track. Is the angular difference between the heading your aircraft is flying at and the track. Okay. So first let's find out expected drift. What is expected drift? expected drift expected drift is the angle between the heading of your aircraft and planned track and planned track. That is your expected drift. Now, your planned track is 074 degree magnetic. The heading of aircraft is 065 degree magnetic. Heading of aircraft is 065 degree magnetic. So drift will be equal to 9 degree. Drift will be equal to 9 degree. Now, is this drift starboard or port? That is, whether this drift is left drift or right drift. Now, the rule says whenever heading is less than track, you are experiencing a starboard drift. Whenever heading is less than track, you are experiencing starboard drift. Watch the video that I have made especially on this. I will put the link of that video in the description box. So in that I have explained the whole concept of drift. So watch that video. Apart from that, so when heading is less than track, you are getting a starboard drift. Okay. When heading is more than track, you get a port drift. That is left hand side drift. So the drift is 9 degree starboard. S stands for starboard. Okay, right hand side. Okay, so since you are getting a 9 degree starboard drift, that is 9 degree right drift, your aircraft heading, the pilot of this particular aircraft has applied wind correction to the left hand side, and therefore the heading has become less than the track. Track is 074, but heading is somewhat like this. Heading is somewhat in this direction. It is not 074, but it is 065. Okay, little bit less than 074, and that is to cater for the winds that are coming from the left hand side and drifting you to the right hand side along with them. Okay, so that's why 9 degree starboard drift. So this is your expected drift. What we have found is expected drift. Now what is the actual drift? What is the actual drift? So I will write it here. Actual drift, the angle between your heading of aircraft and track made good. Actual drift is the angle between heading and track made good. Heading is how much? Again 065. Track made good is how much? Track made good is at a value of 066. 066, right? So drift is how much? Drift is the difference between them. So that difference is 066 minus 065, which is 1 degree. Now whether left or right, so what does the rule says? If heading is less than the track, we have a right drift or starboard drift. If heading is more than track, we have a left drift or port drift. So over here, heading is 065 and track made good. Track is 066. So track is more than heading, and that's why the drift that you are getting is starboard drift or right hand side drift. Starboard drift or right hand side drift. So this is the answer to the third question. Let's go to the next question. What alteration of heading should be made over crane field to fly directly to your destination Cambridge? So let's draw this triangle again. Okay. So your track error is 8 degree. So track error is 8 degree. So this will also be 8 degree, which is your corresponding angle. Okay. This distance is 30. This distance is 40. And off track distance is 4. Right. And this is your closing angle. So if this closing angle will be equal to this angle, alternate angles are equal, right? And now we have to fly directly to Cambridge. When we have to fly directly to your destination, you will use the method of track error and closing angle. You will use the method of track error and closing angle method. So track error we have found out. Now let's find out the closing angle. So closing angle will be equal to distance of track divided by distance gone into 60. So distance of track is 4, distance gone is 40 into 60. So that is equal to 6 degree. So closing angle is 6 degree. Now you have to fly directly to your destination. So the alteration of heading that you will do is the total alteration of heading that you will do is a sum total of 8 degree and 6 degree. Sum total of 8 degree and 6 degree to the right hand side. So Oxford to Cambridge is your planned track. Oxford to Cambridge is your planned track. And when you are 4 nautical miles off track, that becomes your track made good. Now, if you don't apply any correction or closing angle, your aeroplane will continue flying along this track made good. Okay, so to arrest that, or to your first priority will be to stop that or arrest that forward motion, and therefore you will first apply a correction to your heading, which will be your track error. After applying the track error correction, you will be flying somewhat parallel to the planned track, but that is not your goal. You don't have to fly parallel to this track, but you have to fly directly to your destination Cambridge, and therefore to the new heading that you have found, again you will have to add this closing angle so that you get a final heading which will take you directly to your destination, which is Cambridge. Okay, so total alteration of heading will be equal to 14 degree. Right hand side, total alteration of heading will be 14 degree, 14 degree to the right hand side. Okay, so what is the heading of aircraft? Heading of aircraft is 065 degree. It's given in the question. So your heading, new heading will be, the new heading that you will have to fly to go directly to your destination will be 065, the original heading plus the alteration that you are making, which is 14 degree. So new heading will be equal to 079 degree. New heading will be equal to 079 degree. So the first question asks us what alteration of heading is required, that is 14 degree right hand side, and what will be the new heading that is to be flown from Cranefield. So new heading that you will fly from Cranefield will be equal to, that will be equal to, new heading will be equal to 079 degree. Okay, 079 degree. So original heading was 065 degree. Okay, so original heading was 065 degree, correct? From that to 065 degree plus 6, okay, and then 065 plus 8, and 0, after that plus 6, you will get a total of 079 degrees. So let's go to the next question. So before that, I hope you have understood this question. We started with finding track error. Once we get track error, we can find track made good. Then find expected drift, which is the angle between your planned track and heading. Actual drift, which is your track made good and heading. And after that, the alteration of heading and the new heading. Aircraft is flying from Norwich to Oxford at a track of 250. Total distance 96. Heading 260. Ground speed 180. Aircraft departs at 10 o'clock. At 10 o'clock 12 minutes, the aircraft is overhead one location and at 3 nautical mile right of the track. Using the 1 in 60 rule, what is the planned drift? What is the track error? What is the track made good? Okay, same thing. So let's draw the triangle. So your departure is Norwich. This is where you have found yourself to the right of the track. So the 3 nautical mile to the right hand side, this is 3, and at 10 o'clock, at 10:12. So you depart Norwich. Very interesting question. You depart Norwich at 10 o'clock, and at 10:12 you are 3 nautical mile to the right hand side. So now you have time. So the time of travel is 12 minutes. Speed is how much? Speed is 180 knots. Speed is 180 knot. So traveling at a speed of 180 knot for 12 minutes, you will cover a total distance of how much? Convert minutes into hours, which is 900. 900 nautical. Okay, correction. So 180 into 12. So 180 nautical mile into 0 degree in your scientific calculator, 12 minutes is your 36 nautical mile. Equals to 36 nautical mile. So total track error will be equal to distance off track divided by distance gone into 60. So substitute the values 3 divided by 36 into 60 is your track error of pi degree right hand side. Okay. So planned drift. Now they have asked us to find planned drift, which is the angle between your heading and your planned track. So heading is 260, planned track is 250. So drift is 10 degree port or left hand side. Why left hand side? If heading is more than track, you are experiencing a port drift or left hand side drift. What has the actual drift been? Actual drift is the angle between your heading and your track made good. So heading is 260, track made good is 255. So the drift will be 5 degree port. Now why port? Because if heading is more than track, then you are getting a port drift. Okay, so 5 degree left. Now what alteration of heading should be made to go directly to Oxford? So the alteration of heading. So again I have drawn the same two triangles. Okay, if this is 36 nautical mile, the remaining distance to travel will be 60. The total distance is 96, so remaining will be 60. So apply the 1 in 60 rule on this side of the triangle, you get a closing angle of 3 degrees. So now the total heading change that you will need to perform will be 5 plus 3, a total of 8 degree to the left hand side. And therefore, what will be the new heading your aircraft should fly? To go directly to Oxford, your destination will be original heading minus this total 8 degree. So 260 minus 8, which is 252 degree. Okay, why minus? If you are going left, minus it. The very important question is what alteration of heading. So far we have calculated the closing angle and the heading that is required to fly directly to Oxford. Now the new questions, that is the new question. What alteration of heading is required to regain track? Now here they have told you that you have to regain track. That means you don't have to fly directly to Oxford like previously, but you have to regain the track. So when there is a asked when you are asked about regaining your track, you will use double track error method. So let's draw the triangle. So now the talk is about regaining your track. So this is your Norwich Airport. This is your Oxford. This Oxford is your destination, and you will regain track somewhere here. The track error is we have found to be equal to 5 degrees. Track error is 5 degrees. So corresponding angles are equal. If that is 5, this will also be equal to 5. And double track error method means whatever track error you are getting, you double it. So this is 5, then this will also be equal to 5 degree. So now the heading of aircraft is somewhat like this. Let's label the diagram. This is your planned track. This is your track made good. This is your heading. Okay, right? And this distance is a total of 36 nautical mile. The timings given are 10 o'clock, 10 o'clock 12 minutes, and you regain the track at 10 o'clock 24 minutes. 10 o'clock 24 minutes. Okay, so this distance will be how much? So from 10:12 to 12:10:24, a total time is 12 minutes. The ground speed given in the question is 180 180 knots. Okay, 180 knots. The distance will be how much? The distance will be equal to 12 minutes into 180 knots divided by 60. So this will be again another 36 nautical miles. This distance will be 36 nautical miles. Okay. So what alteration of heading is required? So the alteration of heading required will be 10 degrees. Alteration of heading required will be 10 degrees to the left hand side. 10 degrees to the left hand side. Next, what heading should be flown to regain track at 10:24? So alteration, this is the current heading. Okay, heading is 260 magnetic. So what will be the new heading? New heading will be 260 minus 10, which is 250 degrees. 250 degrees. So from this current heading of 260, we will have to turn a total of 10 degrees left and fly a direction of 250 and fly a direction of 250 to regain track at 10:24, to regain or to rejoin the track at time 10:24. What heading change should be made at 10:24? So when you're about to reach or when you are approaching this location, what change in heading will you make so that you don't overshoot this and overfly? Don't overshoot this and overfly this point and then proceed to the other side. So if you continue to fly a direction of 250 like this, you will reach the point, and after reaching the point, if you don't make a heading change, you will continue flying away from that point. You don't want that to happen. So what will you do as soon as you are about to reach that point? Let's say this is your point and you're about to reach that point. Okay, so you start making a right turn. You start making a right turn so that anticipate a turn, start making that turn. So at some point of time, you will directly come over this point and then fly towards Oxford. Then fly towards Oxford, which is your destination. So how much, the question asks you, how much alteration of heading will you make? So the heading alteration that you will have to make will be alteration required at 1024 will be to the right hand side. Everyone agree? So we have to make a right turn. Now by what degree? So by what degree we have to make that? So let's find that out. So we have this triangle. This distance is distance gone 36. Distance of track is given in the question, which is 3 nautical miles, which is 3 nautical miles. So we will find this angle. If we find this angle, we will be able to find this angle because vertically opposite angles are equal. And by that much angle, we will make a right turn. So let's find that angle. So angle equals to distance of track, which is 36, divided by distance gone into 60. So which is 5 degree, which is 5 degree. Okay. So as you are approaching, so as you are approaching this point, you will have to make a 5 degree change in heading. Okay, so what heading change should be made at 1024 and what heading should be flown? So a heading change of 5 degree to the right hand side should be made, and new heading that you should fly now onwards will be equal to new heading that you should fly now onwards will be equal to 250. Okay, so this was 250 and this will be 245. 245 degree. 250 minus 250 plus 5. Correction. 250 plus 5. So you are flying 250 as you approach this point. You will make a right turn. So when you make a right turn, right directions increase in value. So new heading will be 25 255 degrees. 255 degrees. Remember this. Okay. Now estimate the time of arrival at Oxford. Estimate the time of arrival at Oxford. Now Norwich to Oxford is a total distance of how much? Is a total distance of, given in the question, 96 nautical mile. Is a total distance of 96 nautical miles. Out of this total distance, we have so far covered a distance of 36 and 36, 36 and 36 nautical miles. So we have covered a distance of total 72 nautical miles. So the remaining distance is how much? The remaining distance to go is 96 minus 72, which is 24. And the last point we were at 1024. The last point was achieved at time 1024. So now from 10:24 onwards, we are flying towards Oxford. So we have to calculate the time of arrival at Oxford. So we have the distance 24, we have the speed 180, speed 180, right? So time. So time required to fly from this point to this point will be distance divided by speed. So 224 divided by 180. How many minutes? A total minutes of 8. So that will be 8 minutes. So you will reach your Oxford destination at 10:24 plus 8 minutes is 10:32. 10:32. Okay. You will reach your destination at 10:32. So with this was the last part of the question. So again, a quick recap what we have done so far. So we started with normal finding out track error, your planned drift, the track made good direction. Okay. Now in this case, direct distance was not given, but times were given and speed was given. So using speed distance time formula, you were able to calculate distance. Going ahead, we calculated actual drift by definition, and then the next two questions were going directly to Oxford. When they ask you to go directly to Oxford, you will be using track error and closing angle method. So we used that and found the new heading directly to your Oxford destination. The further, we were asked about new heading to regain track. Instead of going directly to Oxford, you're regaining or rejoining the planned track. So in this case, you will be using what method? Double track, double track error method. Double track error method. Okay, so read the question carefully. Whether they're asking you to go directly to your destination or to rejoin the track. Okay, and then estimated time of arrival. So very a long sum, but it consists of only your basics: speed, distance, time, track error formula, knowing the fundamentals of directions. Going left hand side, directions decrease; going right hand side, they increase. So you have to remember that. So with this, we come to the end of this lecture. So I hope you have understood this lecture very well, and you have been comfortable in solving all the 1 in 60 rule sums. The first video, in the previous videos in which we solved the 1 in 60 rule questions. In this video, we have solved questions from the second 1 in 60 rule part 2, which is navigating using 1 in 60 rule. So very important, this both the chapters. So do these chapters thoroughly, the theory as well as the numerical. Okay, numericals will be asked from this chapter. Theory questions are very slim chances of getting asked in the exam. So keep learning. All the best. Subscribe to this channel and share this video with all your friends. Thank you.